Hello, I'm Murali Brahmadesam. In this talk, I'm going to talk about storage architecture challenges in the fintech sector and call for innovation. I'm currently the CTO and head of engineering at Razorpay. I'll just talk briefly about my background. And to motivate the problem in fintech, I'm going to take a sample credit card payment processing flow and explain various entities that are involved, how the data is captured, how the data flows through the systems, and what does a typical architecture look like, what are the challenges in this type of architecture, and what are the areas of innovation. Right? Let's start. Just brief background about me. I started my career at Microsoft. I worked in the distributed file systems that shipped with Windows operating systems, both the client and the server. Then I was a key developer in building a blob storage for enterprises. This was a precursor to Azure Blob Storage. And I worked on a service that was online backup that was like Dropbox for client operating systems. I spent 3-4 years on building big data platforms and ML platforms for Bing. Then I moved on to work for Amazon. I built a customer forecasting platform for Amazon.com that is used by the retail division. I spent bulk of my time building Amazon Aurora service, that is for AWS. This is a relational database service that had compatibility with MySQL and PostgreSQL. I worked on various parts of the stack, starting from the distributed storage to the database engine. I led the overall engineering organization for a couple of years. Currently, I'm the CTO and the head of engineering for Razorpay. We are a fintech startup in India. We offer payment gateway, lending, neobanking, and payroll offerings for businesses. By end of 2022, just to give you the scale, we are going to be targeting at processing $90 billion of total payment volume, and we would have onboarded 10 million merchants. We are well on track for achieving this goal. As of today, 42 out of 50 unicorn businesses in India use Razorpay for their payment needs. You might have heard about various customers that includes government agencies like National Pension Scheme and Swiggy, Flipkart, and so forth. We are the choice platform for startups for their payment needs. So let me motivate the problem by talking about how credit card payment processing works. The first step in credit card processing is called as authentication. Let's take an example where a customer places an order with Swiggy. And once the order is placed, they proceed to pay. So they submit, for example, in this case, their credit card information and the amount to be charged. Right? So Swiggy relies on payment gateways like Razorpay for processing the payment. So Swiggy sends the payment request by giving the credit card information and the customer information to Razorpay. And Razorpay as a payment gateway by itself cannot authenticate the validity of this card because it was issued by a bank. We call it the issuer bank from which the customer got the credit card. So the Razorpay talks to a acquiring bank where it maintains an account for collecting the amount. So sends the authentication request to the acquiring bank. It is also called as a gateway sometimes. The acquiring bank itself may not know about the issuing bank. So it relies on a network. In this case, if it was a Visa or a MasterCard network, appropriate network interfaces are used, and then the authentication request is sent to the network. And the network, by the virtue of that card being branded by a particular network, knows about which issuing bank gave that card, and it talks to that particular issuing bank for the authentication. The issuing bank knows about the customer and the card status and so forth. So it figures out whether this authentication request needs to be approved or not. And based on a multi-factor auth and additional authentication steps, it can send a OTP page, one-time password page, back to the network, and it goes through the acquirer, goes through the Razorpay, and then finally comes to Swiggy, where on the app, that OTP page URL is rendered. Essentially, that OTP page points to the issuer bank's system. So the page is loaded within the app, but when the customer enters the OTP, it goes directly to the issuing bank. And because the customer has configured their PIN with the issuing bank can authenticate that the correct user customer has entered the detail. So once that is done, the authentication flow is complete. If this OTP part is successful, Swiggy knows that the authentication is successful because this page was loaded within their app, right? So once this is successful, we need to go to the next step called as authorization. Authorization is a step where the amount will be held for crediting back to Swiggy. In this case, Razorpay starts the authorization request to hold the money on the credit card, and it goes to the acquirer, which is the gateway, goes to the network, and then authorization request goes to the bank. By now, bank has all the information about the authentication being successful and whether that particular amount is available on the credit card or not. And if that is available and the card is still active, it gives back the authorization response by blocking the amount. From that point onwards, the money is held by the issuer bank, and the authorization response flows through the network, through the acquiring bank, and it comes to Razorpay, which finally tells Swiggy that the money is good to be held. So now the Swiggy can give the product to the customer, and it says the payment is successful. And if the configuration of the customer on the issuing bank is configured such that SMS has to be sent, the SMS will be sent by the issuing bank directly to the customer. So the customer knows that the amount has been taken away from the credit card, right? So this is how the authorization works. Note that the money hasn't moved yet, only it has been held by the issuing bank. After some point in time, Razorpay as the payment gateway will do something called as capture request. It essentially initiates the money movement between the issuing bank and the acquiring bank. So the capture request is sent to the acquiring bank. It goes to the network again, and the issuing bank validates the request and makes sure that the amount that is now asked to be transferred to the acquiring bank is same as what has been blocked before. And the money finally gets transferred to the acquiring bank. And the response comes to Razorpay. Razorpay knows that the money has come to the acquiring bank in its bank account. And once that is satisfied correctly, now the settlement is done to the Swiggy's bank account. Essentially, Swiggy would have registered as a merchant, giving their bank account details, and the settlement happens here. So along the flow of the money, there are many parties that are involved, and they might charge their fees, and the fees are deducted appropriately, and the remaining amount is settled to the merchant. So this is how the payment processing works. So this basically shows the complexity of the number of parties that are involved, the banks that are involved, the network that is involved, various software components that is involved. So now we will dive deep into what is the type of data that is tracked by the payment gateway for doing a payment processing, in this case, a card transaction. So these are the sample entities. This is not an exhaustive list of columns that we track, but just gives you a flavor of what is being tracked. So there is an orders table where the merchant, in this case Swiggy, is placing an order on behalf of a customer, and the amount is given here, and other details are also given to track the details of an order, so that when we want to audit or reconcile, we have all the information. A single order can result in multiple payments, which is tracked in the payment table. And all the money movement is captured in a journal, what we call as a ledger. So each entry corresponds to a step in the money movement. And this, we'll talk a little bit more about this, how it is used and so forth. And cards, obviously, the card detail is also tracked, so that if there is any further things in terms of dispute resolution and so forth. We have enough information about the card that was used for the payment. Gateway is the acquiring bank that has its own fee structure and requirements of which merchant transaction will be allowed and so forth. And it also comes with a cost in using a particular gateway. We'll talk a little bit about how we use various gateways. Then finally, the settlement information is tracked. Right? So this is the list of things that we have to track for a card transaction. So let's take this single transaction in terms of the authentication. That is when the first request is made to the payment gateway for a particular order. So the orders table is inserted. It's around 200 bytes. The payment information is around 400 bytes, and the card information is also tracked. And at this point, a gateway has to be chosen to be sent for the further processing. The acquiring bank has to be chosen. So some information is read from the gateway details that we have been onboarded in a different way outside this payment processing. So essentially around 1 kilobyte worth of data is being written during the authentication step. And authorization step basically updates few columns in these tables. And when we say capture, this is when the money movement happens, and that's where the ledger gets inserted. So around 1.5 kilobytes of data is being updated, inserted into the capture for the capture step. And during settlement, the money is actually moved into the merchant account. So the ledger is again updated. Essentially, for a single card transaction, regardless of the amount of the transaction, whether it is 1 rupee or 1 crore, 5 kilobytes worth of data is being captured in the OLTP system. This doesn't include all the secondary indices and other requirements which might come because of the various operations that we have to do. But this is just plain vanilla. It requires 5 kilobyte worth of data to be captured. So I briefly talked about reconciliation. As you saw in the payment processing, there are various entities that are involved: the issuing bank, the merchant, the acquiring bank, the network itself, Visa, MasterCard network, and so forth. So we, as a payment gateway, has to reconcile the data that we captured for a particular payment with the data that is there in the parties that we interact with. So to make sure that the receivable that we have tracked is what is there in the gateway and so forth. And that is process is called as a reconciliation. And this is an offline processing that does in a periodic way. This is how we know that all the systems are consistent. Right? Let's talk about how it is performed. So all the data that is relevant to the money movement in the payment gateway is tracked in the ledger. So all its mutations, how the money moved, if there are multiple payments for a particular order, all of them, if there are refunds, if there are rebates, if there are fees, all of that is captured in the ledger. And periodically, we receive the transaction details from various gateways and banks offline through various file formats and sometimes in APIs. So now we need to compare the data that is there in the various parties that we deal with and the data that we have, and we compare it in offline processing system. And if there are inconsistencies, we send for review. So this process is called as reconciliation. So during this process, various data is being processed and also returned. So there is a data processing need here. Let's talk about analytics. Fintech is all about managing the risk. So we involve in giving loans, credit cards, and so forth. So understanding the risks and taking appropriate measures is very important. So we do that by processing the information that we have, and we also acquire data from external sources to compute this risk. And there is also money leak detection, fraud. We have, in terms of targeting needs, we have multiple products that we can offer to our customers. So we do some prediction on whether a particular product will be meaningful for the customer. In terms of success rate analysis, as I initially mentioned, the gateways that we talk to come with fees, and they also always do not succeed. So the success rate and the cost trade-off is always taken into account for every payment, and we choose the appropriate gateway to send the payment request. And obviously, we want to understand a little bit more about our customers, our products, and so forth. So a lot of BI happens. How is it performed? We built a data lake. Essentially, we take the OLTP data and any auxiliary data like credit scores and so forth, and then we accumulate and then process them using various workflows, ML workflows, and we build dashboards for our business intelligence. So a lot of reports get generated, a lot of analytics happens. So when we talk about overall data size, there is an important piece of data that is tracked in terms of application logs. So this is something that the developers need for debugging, monitoring, auditing, and so forth. And this tends to be very verbose and so forth. And for auditing and compliance reasons, we need to store for a longer period of time. So this also adds up to the cost of running a service. So rough ballpark per transaction, payment transaction, we need approximately 5 kilobytes worth of data, raw data for the OLTP. And then it becomes 50 kilobytes because various mutation happens or materializations depending on the usage patterns, how we need to produce reports and so forth. The data gets duplicated in various forms. So it's approximately 10x the growth into data lake. And application logs, as I mentioned, we generate around 10 megabytes from all the microservices that we use. So if you look at overall the amount of data that we need to process, per month, approximately 170 million transactions we process in the payment gateway. It generates around 850 GB worth of OLTP data, 9 terabytes of data like data. And the application logs are retained for 90 days. It amounts to 2 petabytes. And this is sort of a fixed cost because we garbage collect after 90 days. So per year, approximately half a petabyte worth of data lake data is being generated, and 10 terabytes worth of OLTP data. As I mentioned, this doesn't include all the indices and so forth. So this can be, maybe 2-3 orders more in terms of the OLTP data. And data lake depends on the number of processing that we have to do, right? And these are all accumulated. These are not garbage collected. So over time, it piles up. So when we talk about architecture to handle this type of processing, it's a very typical architecture where you have an API layer where merchants call into this payment gateway through various APIs that gets pushed into microservices that understands various flows, like the payment processing for credit card versus various other means, direct transfer, net banking or UPI and so forth. There are various payment vehicles that are available, methods that are available. So the microservices handle those cases. And the data is persisted in OLTP databases. These are typically relational databases. The changes in this database is captured in the CDC stream, which is change data capture stream. Typically, it's Kafka, and gets pushed to data lake for further processing, which generates BI reports and various machine learning workflows are run. So this is just a typical architecture as a reference for us to understand the challenges in creating such an architecture. So let's talk about challenges and hopefully motivation for innovation. So I want to talk a little bit about a merchant use case where is a gaming use case where just before the event, a sporting event, there is a big spike in the traffic volume, and this is logarithmic scale. So you can see that it is 3 orders of magnitude spike, right? So the payment system has to suddenly scale up to handle this bursty traffic. And this is just one sort of a use case, right? I'll give you another example where this is a stock funding scenario where customers load up their stock account with money through the bank, through the payment gateway. And then when the market opens, just after 1 hour or 2 hours after the market opens, there is a spike in the trading. And before the market closes, there is a spike in trading. And this is sort of a typical pattern, like a M shape that happens every day. So depending on the use case, depending on the merchant, the patterns are very different, right? And the payment system has to handle these sort of bursty traffic. So in case of the gaming case, we need to scale very quickly to handle the spike. And it depends on an external factor when the sporting event happens and so forth, right? In case of stock trading, during the market period, the spikes happen, and some of them are predictable. But the key part is to handling these things, the system has to be able to run it very efficiently. Scaling up fast is possible, but typically we are very conservative in scaling down. So it's a lot of inefficiencies there. And even though there is predictable workloads for various merchants, we have 10 million merchants patterns to deal with. So it becomes quite challenging to adapt to various traffic patterns. Let's talk about availability. So if you see this graph, this is the weekly traffic pattern. The key thing to note is the pattern, the call volume never goes to zero. That means that the system has to be available all the time. One of the reasons is we also deal with important export traffic payment related to that. So that means that the systems that we use for the processing cannot have downtime. So we need innovation in terms of zero downtime capability. And that is very hard to achieve. As you know, the database maintenance, whether it's schema management or version upgrades and so forth, incurs a downtime. So we need to make sure that these systems are not brought down. And it takes a lot of effort to make it with sort of a blue-green type of a deployment and so forth. That requires a lot of engineering effort to make sure the availability is not affected. While the payment processing is done, there is spikes in traffic and there is also denial of service. When these things happen, other merchants should not be affected. So we need to make sure that our systems can handle these type of access patterns. And deployments goes without saying. Usually that's where most of the problems occur in terms of deploying software. Because of the need for zero downtime, we need to deploy with better practices and slow rollout and so forth. Let's talk about efficiency. As you can see, for building this type of architecture, we rely on a lot of technologies. A lot of diverse technology means that we need to understand a lot of these technologies on how to use them, and running it efficiently is very hard. Right? Application logs tend to become very bloated. It's very verbose. So a developer might not think about the cost when they are writing a lot into the application log. So we need to be paying attention to how to do this thing. Right? Auto scaling policies I alluded to earlier. Scaling up can be done very fast, but then scaling down is very conservative, in which case you are running an inefficient system. Data lake is another a costly piece of technology that we use, where the cost keeps growing because the data may not be modeled well. As new use cases come in ad hoc fashion, the data is duplicated and so forth. So keeping the check on the cost of the data lake is very important. Let's talk in terms of compliance and regulations that comes to a fintech system. Right? Auditing, we want to know how the data changed, why it changed, where it changed. The keeping track of the provenance requires a lot more data to be tracked and maintained. Data integrity, when the data moves between the systems and the microservices, between databases and so forth, we want to make sure the correctness is not compromised. There are various personas that access the data, operators, and so forth, and developers and whatnot. We need to make sure that we have granular capability in keeping access control. And while this data moves between the systems, we need to make sure that the data masking is done, encryption is done at data at rest and transit and so forth. So all of these things requires a lot of thought process, and using the right technology, it requires a lot of innovation to simplify this piece of requirement. And an important thing about disaster recovery, when we design these systems, it's important to keep in mind of how to achieve low RPO and RTO guarantees that would allow business continuity. Right? For example, understanding the dimensions of failures of a dependent service, like you're running databases. Is this thinking about what availability zones that are being configured? Is it using a single availability zone or multiple availability zone? When you're running your API fleet, is it concentrated on a single availability zone? So we need to think about all of these things to make sure the system is resilient. In terms of backups, how do you secure your backup? Good practices to be followed. are across accounts, across region, and so forth. And these are harder to implement it correct, right? So we need to solve that problem. Having backups is one thing, but making sure the backups are restorable and you can get back the whole stack of the software running in a period of time is a very difficult problem. So practicing restores, making sure the entire stack can come up, that is a problem to be solved. As a startup, we want to expand to various markets. So that means that the systems that we build has to be having some mindset of globalization and localization. And this is very hard to do when you are trying to work deep into a particular market, right? The technologies that we use may not be available in a country. For example, the AWS cloud may not be available in a country that we may want to expand to. So how do we build the system? By trading off correctly in terms of using heavily a single cloud versus building a multi-cloud. And there are a lot of literature out there and design patterns and whatnot, but it's still a challenging problem. So let me summarize. I briefly touched upon the breadth of the problems, how the data moves between various systems to doing payment processing. So the key part is building a highly secure, available, scalable, performant storage architecture that is cost efficient is still a hard problem. Right? The key thing is cost efficient, because there are so many building blocks that are available to be put together and so forth. Either you need to understand a lot about them or pay a lot of money for achieving your requirements, but then it also limits you on how you expand to various markets. So the building blocks that are available, putting them together requires a lot of ramp up time to understand various trade-offs, how to use them, how to operate them efficiently, how to manage them, and so forth. So self-managing is very hard. And if you go to a managed service, that comes up with a lot of trade-offs also. So when you use a lot of building blocks to build the application, it's not easy. So there is a scope for improvement there. And one of the critical things that I would like to address a little bit more in the future at Razorpay is to figure out what is the right infrastructure to use, because it's good that we can take advantage of a single cloud with all the services and make them integrated and so forth. But we lose the flexibility in terms of going to various markets, and the cost function is also there. So coming up with the right trade-offs on what technology to use when and so forth requires a lot of thought process and a lot of let's go solve these challenges. Thank you.